Hello and welcome all to a new session of data science using Python programming language. Now in this session we are going to see the resampling techniques. Resampling techniques is something which will work on the imbalanced data set. When the classes are not balanced for a categorization output variable like classification algorithms, that time we are going to balance them with the help of resampling techniques. So let's just give a light on this particular technique. What do you mean by resampling, or what do you mean by imbalanced data? It's a scenario. What do you mean by imbalance first? It's a scenario where the number of observations belonging to one class is significantly lower than those belongs to the other classes. This problem is predominant in scenarios where anomaly detection is crucial, like electricity pilferage, fraudulent transactions in banks, identification of rare diseases. In this situation, the predictive model developed using conventional machine learning algorithm would be biased and inaccurate. This happens because machine learning algorithms are usually designed to improve accuracy by reducing the error. Thus, they do not take into account the class distribution or proportion of balance of classes. So, when we are going to make use of yes and no, and if you're having only 50-50 situations, 50 people are saying yes, 50 are no. So, features we can find how yes and no is actually defined, but only 5% people are telling yes and 95% are telling no, then it will be very difficult to find the criteria to separate the classes. So what we require both of or all of the classes should have equal importance into the data set. So when balanced data set is not present, machine learning cannot find the novel insights inside it. Now, why to work on imbalanced data? Machine learning algorithms tend to produce unsatisfactory classifiers when faced with imbalanced data sets. For any imbalanced data set, if the event to be predicted belongs to minority class and the event weight is less than 5%, it's usually referred as rare event. Okay, so when one of the class is having only less than 5% entries inside it, so rare events are there. So to find a novel insights inside, it's very difficult to find it. Okay, that's why it's very necessary for a data scientist, for a machine learning engineer to work correctly on the imbalanced data set. Let's go with an example. Let's understand this with the help of an example. For example, in an utility fraud detection data set, you have the following data. For example, I have total observations in the data set, that is total number of rows in the data set are 1000. Out of it, fraudulent transactions observations are 20 and non-fraudulent transactions observations are 980. It means that event rate is only 2%. Only 2% time out of 1000 frauds are occurred. So our output variable is fraudulent and non-fraudulent. But the problem is that fraudulence are 2% and non-fraudulence are 98%. The main question faced during the analysis is how to get imbalanced data set by getting a decent number of samples for those anomalies given the rare occurrence for some them. So rare occurrences are there. How to find a novel insights in it? How to create a perfect classifier which will classify this kind of the data sets? So this is the challenge that we will face in the machine learning. The conventional model evaluation methods do not accurately measure the model performance when faced with imbalanced data sets. Standard classifiers like decision tree and logistic regression have a bias toward the classes which have number of instances. Remember this, they are biased toward the classes which have number of instances. Means if you're having instances more for a particular class, so bias will be towards that particular classes. You can observe that in the confusion matrix. The number of observations are more, their accuracy of that class is more, means the recall of this particular class will be more. So they tend to only predict the majority of class data. The features of minority class are treated as noise and often ignored. Okay, this is very strange thing that we observe in machine learning. Thus, there is a high probability of misclassification of the minority class as compared to the majority class. So that's the main challenge that we focus when we have imbalanced data into the data sets. Now, few more examples go for that. Apart from fraudulent transactions, other examples of common business problem with the imbalanced data sets are data set to identify customer churn, where a vast majority of customers will continue using the service, specifically telecommunication companies where churn rate is lower than 2% only. Okay, then what to do, how to find why, what's the reason behind it. Data set to identify rare diseases of medical diagnostic. Okay, if rare diseases are there, then it's very difficult to identify. Natural disaster like earthquake, they are not very regularly happening, they are happening rarely. So to find the reason, to find the categorization of them, it's very difficult for us to use in that case. So that's why imbalanced data set working is very important task, very important work in the machine learning is. Now to overcome on that, now resampling techniques are introduced. Dealing with imbalanced data sets entails strategies such as improving classification algorithm or balancing classes in the training data. That's what data pre-processing is done before providing the data as input to the ML algorithm. The latter technique is referred as its wider application. The main objective of balancing classes is to either increasing the frequency of majority class or decrease the frequency of majority class, increase the minority class and decrease the majority class. This is done in order to obtain approximately the same number of instances for the both classes. So what we do, that's what simple technique that we have to prefer. Majority class can be decreased or minority class can be increased. So this is what we call as the resampling. There are three methods which we apply into the resampling here. The first method is called as random under resampling. Second is random over resampling, and third is an algorithm which is called as SMART. Now this technique can be applied and used correctly into the machine learning algorithm. Let's go one by one, theoretically, and then we go for practically also. The first method is called as random undersampling. Random undersampling aims to balance a class distribution by randomly eliminating majority class examples. Randomly eliminating majority class examples. This is done until the majority class and minority class instances are balanced out. Let's see. For example, total number of observations are 1000 and fraudulent are 20, non-fraudulent are 980, event rate is 20%, 2%. In this case, we are taking 10% samples without replacement from non-fraud transactions and combining them with the fraud transactions. How to? So out of all non-fraudulent transactions, random undersampling will be 10%, that is 98 randomly. Out of 980, 98 are randomly taken. Total observations after combining them with the fraudulent observations will be 118. So 118 out of 118, now 20 samples will be fraudulent and 19 will be non-fraudulent. So event rate for the new data set undersampling will be 20 by 118, that is 17%. Now it is somewhat improvement, 15% improvement into the class of fraudulent transaction that we are improved here. Okay, in this way random undersampling works. Okay, what are the advantage of it? It can help to improve runtime and storage problems by reducing the number of training data samples when the training data set is huge. Okay, in that case, so runtime, because obviously undersampling is done, number of instances are reduced drastically. Disadvantages: it can discard potentially useful information which could be important for building rule classifiers. Possibilities there, because randomly we selected, and random selection can have some improvement, means some drastic loss of the data also. The sample chosen by random undersampling may be a biased sample and it will not be an accurate representative of the population, thereby resulting in inaccurate results with the actual test data set. That's a problem in random undersampling. Now in contrast to the same, we are having one more method which we can use. It's called as random oversampling. Oversampling increases the number of instances in the minority class by randomly replicating them in order to present higher representation of the minority class in the sample. Now, let's continue with the similar example. Total observations are 1000, rows are 1000, fraudulent are 20, non-fraudulent are 980, event rate obviously 2%. So, in this case, we are replicating 20 fraud observations 20 times. So, non-fraudulent are 980, fraudulent observation 20 times, minority class. So, we are getting 20 into 20, that is 400. Total observations in the data set will be 1380, and now event rate, out of 1380, 400 are fraudulent. So 29% in one class and remaining 71% will be in other classes. That is what we term as random oversampling. So this way, this random undersampling and random oversampling perform the operations. What's the advantage of using oversampling? Unlike undersampling, this method leads to no information loss. Remember, information loss is not present. Undersampling contains the loss and outperform the undersampling. Why? Because number of samples are more. So as data set is more, data is more, and even event rate is also good than the previous examples. That's why outperforming is good. Disadvantage: it increases the likelihood of overfitting since it replicates the minority class event. That's why overfitting may occur, and obviously number of samples are more, the time required for the ML algorithm will get decreased. It will be more time will be required for this case. That is what disadvantage and advantage that random oversampling are containing. We'll go to SMOT after this, after the practical implementation of these two problem statements here. So let's go for this random sampling. Okay, so let's check it out. Now, in order to use this, I need a package called as Imbalanced Learning. So the package name is IMBlearn. You just have to install that by using this methods. So let's check it. Okay, sudo pip3 install IMBlearn. Okay, so we require the IMBlearn package here. So this IMBlearn package contains the classes by which we perform the random oversampling, random undersampling, and the SMOT method. Okay, so check it out. IMBlearn I have installed in my system by using this particular command, pip command. You have to install the IMBlearn. Okay, so let's read the packages. Pandas as PD, NumPy as NP, Seaborn I'm installing. Then pre-processing package is also present. Now, in IMBlearn undersampling sub package, I'm importing random undersampler. Okay, and Tomk links also. I'll show the meaning of this. Then oversampling, random oversampler, and SMOT. SMOT is also coming under the oversampling package there. So let's run this. We'll import all the packages. Okay, so required a TensorFlow backend. So remember that TensorFlow, if it is not installed, you need to install TensorFlow package also. Okay, they are installed. Now let's check this one. The file or the dataset that I am going to use over here is the creditcard.csv, which contains fraud transaction and non-fraud transactions inside it, and that file I am going to use it here in this because credit card frauds are very less as compared to the original transactions there. So let's go for the credit card for transaction detections. So let's check it. Yeah, so file is very big actually. You can check it out, 150 MB. It's very big file. This number of credit card transactions are present there, and this transaction we need to open. Check this. I'll just show you snapshot of all time, and these are the transactions. See this all, and here the class is present. These are the amount of this kind of class. So class contains 1 and 0. Okay, fraudulent and non-fraudulent transactions inside it. Okay, in it all. just check it out all. Okay, I'll just not open that because file is very big, it will take some time for reading it. So credit card.csv, this one, and then we'll see the number of sample data set, how many samples are there, and after that I'll check how many classes are there, means how many class belongs to 0 and 0 and 1. So class 0 is the non-fraud transactions and class 1 is a fraud transaction. So we'll read this file data set, then check how many transactions are there, that is length of it, and then I'll find the percentage of fraud and non-fraud transactions from there. How to do this? Class 0 round class 1 value count 0 divided by length of data set into 100, and see this round contains all of this data set of class, how many value counts are there, okay, for 0 class, okay, value counts of 0, how many are there, divided by length of data set into 100, and 2 positions given after that. Similar to that, fraud in transactions round off, so it contains from here to here, first parameter data sets class which contains 1 divided by length of all into 100, and 2 points are present after this. So when I run this, check it out, I'll reading the total file of 150 MB, then how many transactions are shown, transactions, and out of all how many class 0, how many class 1, check it out. Now here event rate will be shown, number of samples are 2,84,000 in it, and class 0 are 99.83%, means out of all non-fraudulent transactions are 99.83%, and fraud transactions are 0.17%. so too much difference, huge difference is there. 99.17% is a negligible value. Okay, so it's completely imbalanced data set that we are going to have it here. And now let's make it balanced. So before that, see few more technique to check that data sets visibility. Now in Seaborn we have count plot data set for class, so check this one now. Now see the difference. This is wow, 0 non-fraudulent and this is 1, so there is no comparison now. Okay, so 1 is negligible, so count plot will show you one class is completely less, huge, second class is very huge, 99.83% is present there. Okay, now let's apply the first method, random undersampler. Now random undersampler will take it. So first of all, I need to change my element, so X data, okay, except the last column, all other will be the first, that is just as I'm removing the last column, remaining other taken as the first elements there, and the output variable, okay, which I'm taking the last variable. By using this ILOC method and negative indexing, I'm making use of it. So last class I'm taking in Y, and first all classes I'm taking in X. Now let's create the object of random undersampler here. Now random undersampler object I am creating, random state I am keeping 0, so that randomization of all will be same. I can use any, randomization will change if you change the seed point in random state, res. Okay, now object is created. Now res dot fit resample. Remember, resampling is a pre-processing step, so before actually applying the data to ML algorithms we have to resample that. So that's why we are done this, res dot fit resample. So it's not containing fit transform, here we have fit resample. Resample this data, this is input, this is output, resample it. What is undersampling? Okay, so you got this resample data X, resample data Y. Okay, so convert that into data frame format, first in X, second is also there, so converting into data frame format. Okay, now after undersampling majority of class total, what will be the size of the data set that I am printing here? Okay, either we can print the length of X or print the length of Y. Okay, that's what we can print. And now out of all, how many belongs to class 1, how many class 0? Same thing which I have used above, I'm using here also. Class 0 round of Y raise class dot count 0, because I'm taking Y only. Why? Because Y the output variable which is separated. Class value counts for 0 into total, okay, percent of data set, same counts of 1 divided by total of the data set. Check this out now. Now see, after undersampling, majority class total samples 984. 984 are there. Out of this 984, 50% belongs to first class and 50% belongs to second class. Correct? 50% first class, 50% second class. So data is completely balanced. Now why? Let's check that with the help of a graph. Yes, see this. Almost so 984, so we'll have that data as 492. Correct? So 492, this will be 0, 491 will be 1. Okay, balanced both. But the problem there is that it is what we are using undersampler. So if you compare that 2,84,000 data converted into 984 samples only, so we got only few percentages, some percentages of data samples out of it. So huge data loss we have occurred from this sampling, but our data is balanced. Fine. This is what we call as undersampling. Let's go for the oversampling. Now similar operations I have done here, but I'm changing the class only. How to? So this is input x data, output y data. Now here random oversampler, random set equal to 0. Correct? RES I am taking x rest, y rest, x resample, y resample, RES dot fit resample, x data, y data, convert into data frame format. Okay, and after this check total number of samples available. Think how many are from class 0, how many are from class 1, that is class 0's non-fraudulent and class 1's fraudulent data sets, and then check how many are present there. I'm just running this code. Check this out. Okay, oversampler 5,86,000, sorry 68,630. So from 2 lakh, okay, it is converted to 5,68,000. Out of all, 50% class 0, 50% class 1. Yes, this is 50-50 what we achieved here. Correct? And now let's see the graph of it. See this, more than 2,34,000, 2,34,315. That's a number. That's we achieved from this class 0, class 1. Okay, this is what we achieved from oversampler. Accuracy will be better for this particular case if we use this data, but remember the time required to execute or use this algorithm, this data in the algorithm will be more as compared to the undersampler. Correct? Okay, this is what the over and undersampling techniques are used, by which we can balance the data set and we can achieve more good reasonable accuracy out of this particular data set balancing. Okay, let's go for the third kind of algorithms here, that is what we call as SMOT. SMOT is synthetic minority oversampling technique. Synthesizes new minority instances between existing minority instances. It randomly picks the minority class and calculates k nearest neighbor for that particular point. It's an algorithm, not based on the simple mathematical theory. Finally, the synthetic points are added between the neighbors and the chosen spot. So here it's using the k nearest neighbor algorithm to find the nearest neighbor from the minority class, and based on that the selection of the data is done. That's what the SMOT will do for us. Now SMOT is coming under the oversampling. Okay, so you just can check this out. SMOT we are taken from the oversampling here. Okay, now let's go for the SMOT. So same task I'm doing over here. Data set input, this is output. Okay, then object of SMOT. SMOT random set equal to 0, and its RES objects we have created. RES dot fit resample input and output, and then we got this resample data, convert data frame format. Same SMOT, how many SMOT object we got, and then percentage of them also after this. So I'll just run this file, run this code, and now check the output. It's taking some time. Yes, 5,68,000. Okay, 5,68,630, almost similar operation that oversampling has done, smart has also created. Okay, check this now. Okay, and smart's output is 50-50. Class is balanced. If you check the output of it, say this. Okay. Balanced data set we achieved from the given data, and if you see the counts, so they are also same. Say this. Our use class, so 2,84,315 is present in both the classes. Okay, so this is how the smart can be used. Now along with the smart, there is one more technique that we can use called as cluster based oversampling. Now KM is clustering. Algorithm is independent applied to both class instances, such as to identify clusters in the data set. All clusters are oversampled such that clusters of the same class have the same size. Remember, oversample so that clusters same class will have same size. So let's go for this. Total observations 100, positive 90, negative 10, and event rate is 2%. Okay, so check this out. Now I'm having multiple different clusters. Out of all 100, we are having cluster 120, then 30, 12, 18, and 10. And majority class clusters contains 8 and 12, something like this. Okay. Now, after oversampling, all clusters of the same class will have the same number of observations. Cluster 120, 20, all are 20, and minority class will contain 15, 15. Okay, same observations there. Okay, that will be the somewhat close to the original positions there. Okay, after oversampling. Okay, and if we want to apply that cluster centroids, we very rarely use method actually, but check this out. We can make use of this particular system in clusters centroids. There is a class called as cluster centroids. With the help of class cluster centroids, we can do the same operations here also. But this cluster centroids class is applicable when we have more than two classes. More than two classes are present. That time this method is more beneficial and useful for us to get used to work on the imbalanced data set. The operations which are shown over here, they are same. Okay, it's presented to undersampling, and the operation that we do here, that's also same, but the method is cluster centroids. This particular class I'm using here, and set is 0, and all other operations are same. We just check it out here. The number of entries are too much, they are high. Cluster operations are taking too much time to run this particular file. So just try on your system and check how clustering technique can be used to balance your data sets. But first three, that is oversampling, undersampling, and the smart, these are the commonly used methods which we can apply to make your data set balanced. That is not actually balanced. So if you want to work more on this, many more small algorithms are present in Imbalanced. So this first link present there, imbalanced-learn.freedocs.io, where we can find all the information about the operation or data science algorithm which will work on the imbalanced dataset operations only. This one, and few more algorithms are yet coming. You can find them on IEEE. Many advanced algorithms are there, complex algorithms are also present. But when we are working on common traditional machine learning algorithms and we are having a problem of imbalancing the data sets, these commonly used resampling techniques are very much beneficial and useful for almost all the cases that I have seen in implementation of this DS and ML algorithms there. So try by your own. Presentation programs are given to you. If any doubts, questions are there, the communication mechanisms are there on the screen for you. Thank you. Thanks a lot.